In this video, we'll look at how to graph a parabola and how to take an equation that is not in standard form for a parabola and get it into that standard form using completing the square. So here I've rewritten the standard equations just for reference, but the idea behind graphing the parabolas is you want to start off with the vertex. So find wherever that coordinate is and plot that point. The next two things we're going to need are both the focus and the focal width, and we need to combine those to find other points on the parabola. The focus itself is not on the shape, but it does help guide the shape of the parabola. So what we do is we start with the location of the focus, and then we plot the other points by going half the distance away from the focus. The reason we go half the distance is because the focal width is the width all the way across the parabola. So if we're starting at the focus, which is halfway across, you just go half the width across, and that'll give you 2 more points on the shape. So I'll demonstrate that on the next couple slides. So as I described in the last slide, the first thing we want to identify is the vertex. And since this one is already in standard form, the h value is -1. And the k value is 2. Just make sure you remember to change the signs on the numbers next to x and y. So my vertex is -1, 2. Next, I want to try to figure out the focus. And for that, I will need to know what p equals. So make sure you remember to identify that if 4p is equal to 8, it's always 4p equals that coefficient. Make sure you divide the number by 4 to get your p value. So p is 2 in this case. And I need to take that number and add it to the x coordinate because that's what p is touching, the x variable. So if I take the x coordinate of my vertex and I add 2 to that, then I will have the coordinate +1, 2 instead of -1, 2. And the last piece of information I want is the focal width, which is just the absolute value of the number out front. So if you take the absolute value of a +8, it's still a +8. So for the actual graphing part, start off by plotting the point of the vertex. So that's left 1 and up 2. And then I need the coordinate for the focus, but I'm not actually going to draw a dot there. It can help you if you want. Feel free to draw that point, but especially if you're doing this on MATLAB or a computer program, they probably don't want you to draw that dot in since it will guide the shape of the graph, but it's not actually part of the parabola itself. What I need to do from this location where the focus is stretch it half the focal width away. So starting from 1, 2, I'm going to go up 1, 2, 3, 4 and draw another dot. Or I could have done that half the focal length away in the opposite direction and gone down 1, 2, 3, 4. So I started from the focus and then I went half this distance in the other 2 directions. That is enough to get a good idea of the shape of your parabola. And if you're doing this on a computer program like MATLAB, it'll probably only make you draw one of them. It'll have you plot the vertex and then one of these other points, and it'll fill in the rest of it for you since it's a symmetrical shape. Here's another quick example doing the same thing. I'm going to start off with the vertex. And the numbers next to x and y, making sure to change the signs. That will be -2 and +3. And then for everything else, I need to figure out what p equals. And this one actually uses the same number. The coefficient is 8. So that means again that p must be 2. So for the focus, on the last one, I was adding from the x coordinate. This time I'm going to be adding p to the y coordinate because that's what p is touching. So here's the coordinate for the vertex. If I add p to the y value, this will become -2, 5. And my focal width, the absolute value of 8, is still 8. So plotting this point, the coordinate of the vertex is left 2, up 3. And then my focus is left 2, up 5. But I'm not going to draw that dot. I'm just going to start from there. And then half the focal width would be 4. So I'm going to go 4 to each side. 1, 2, 3, 4, draw a dot, and then go back to the focus, 1, 2, 3, 4. And that's just to show that the focal width all the way across the parabola passing through the focus is a width of 8. That's what these two numbers are indicating for me. So now I can just extend from the vertex, and that gives me the pretty good guideline for what the shape of the parabola should look like. Here's the last thing I'll have you guys doing with a parabola. It's when it's not going to be in standard form yet, you're going to change it into standard form. And to do that, you're going to have to do something called completing the square, which I hope you guys will remember from Algebra 2. So the first step is to identify which variable is squared. If there's an x squared or a y squared, then you want all of the x's on the left side of the equation, and you want to move all of the numbers by themselves, the constants, and the other variable that does not have a square to the right-hand side of the equation. The second step is to look at your x squared or y squared term and see if there's a coefficient on it, like if you have a 2x squared or a 5y squared. There shouldn't be a number on the x squared or y squared. If there is, you need to factor that number out or divide everything in the equation on both sides by that number to get rid of it. You can't complete the square if there's a number attached to these squared terms. Once that's taken care of, or if it was already in the appropriate form for you, you do the completing the square process, which I will demonstrate for you. And if you need a refresher on it, there is another video I've made in the review section that you can look back at for completing the square. You're going to do that to get the x's or the y's, whatever's on the left-hand side, into the factorable form that you need. And the last step, since you will have added some numbers to the other side of the equation as well when you complete the square, you just need to look at that x or y to the first power and factor the coefficient out. It should just be a y inside the parentheses or an x inside the parentheses. So if you have a number like 10 attached to the x, then factor 10 out from everything on the right-hand side, and that will create the 4p term. So here's the example of what I just described. The examples are usually phrased in one of two different ways. Sometimes they will say prove that it's a conic, a specific conic like a parabola or an ellipse. Sometimes it will just say get it into standard form using completing the square. But either way, they're asking you to do the same thing that I just described. On this particular question, I see that I have a y squared but not an x squared. So I'm going to move all of the y's to one side of the equation, and I'm going to move everything else to the opposite side. So the negative 6x, that'll be a positive 6x on the other side, and the positive 13 will become a negative 13. Now you'll notice I left kind of a blank space in here, and that's for the completing the square step next. I don't have a number attached to the y squared, so I just get to go straight into this next part right away. So you take half of the middle number. Completing the square is half of b, so b divided by 2, and then you square it and add that number to both sides of the equation. And it seems random because we're just adding a number to both sides of the equation for seemingly no reason, but I'll show you the purpose for that in just a moment. So half of b, half of 2 in this case, is 1, and 1 squared is 1. So I'm just deciding to add 1 to both sides of the equation for what seems like no reason at all. The reason we're doing that, though, is because it will make the left side of the equation factor down very nicely. We're looking for two numbers that multiply to 1 and add up to 2, but as a shortcut, it will always be the variable you have and half of the middle number. So half of 2 is 1, and it will always be that binomial squared. And sure enough, you could test that by saying if you had y plus 1 times y plus 1 and you distributed it out, it would give you y squared plus 2y plus 1. Or if you are comfortable with factoring, 1 times 1 is 1, 1 plus 1 is 2. That's why this is the correct factorization. So that shortcut is handy because it will always come down to be the variable and half the middle number. And on the right-hand side of the equation, I have a negative 13 and a 1 that I can combine together because those are like terms. But the last step I gave you guys was that you should not have a number attached to your variable on the right-hand side. So whatever number you have attached, whatever coefficient you have, you just need to factor that out from the right-hand side of the equation. The left-hand side is done. I'm going to leave that as is. So if I take 6 out of everything on the right-hand side, 6x divided by 6 is x, and negative 12 divided by 6 is negative 2. So you could distribute and make sure you did it correctly, but now I have my values, my standard form of the parabola, and from here they could ask me to go on and find the vertex, the focus, the directrix, whatever I need to, because I now know that h is 2, k is negative 1, and I know that 4p is equal to 6, which means p would be a fraction on this. It makes it a little bit harder for the computations, but I know that p is equal to 3/2 in this case. So that's it for the notes. Just make sure you guys are comfortable with that, completing the square process, and making sure you meet the requirements for doing it, like not having a number in front of the x squared or y squared on the left-hand side first.